Logarithm is an aspect of mathematics that is very, very important. Logarithm can be considered as inverse of indices. I don't want to waste much time on this topic. So many people have come to me and they told me about how confused they get to be in studying logarithm. Logarithm is very interesting and fun. It's an aspect, just like playing game. You know, indices, you know it forward. Logarithm is knowing it backward. Now let's look at an expression like this. X raised to power n equals to y. X raised to power n, this is the power, and this is the final result, y. You know, I can also make x to stand alone without any power in this situation. So, y will be the one to carry the power, but the power y will carry will be reciprocal of n, just like we are treated in indices. So, we can just say x raised to power n raised to power 1 over n again will be equal to y raised to power 1 over n, you know, for that operation to happen on both sides. So this one cancels this. So x is equal to y raised to power 1 over n. Considering this, the two of them are still indices. This is indices, this is indices. Take that. But in logarithm, we are trying to make this power here the subject of this equation. How do I mean? When we have an expression like this, x raised to power n equals to y. To bring in logarithm into this, what we do is this. We make n to be here and log of y to the base of x. You can see, this x will now be the base here, and y will be the arguments. Y will be the arguments. Let me write it. So you can see. So, I just want you to have this picture. This relationship and this one. So anytime you are seeing this, automatically rewrite it to be like this. What am I saying? Anytime you have n equals log y to the base of x, automatically this means that y is equal to x raised to the power of n. That's all. Just have this in your mind. Once you can do this, everything in logarithm will be child's play. Now let's look at some expressions. You can consider it as the rule, you can consider it as law or whatever. But the first one, please take note of this. When we have x raised to power n equals to y, so we can easily write that n, this power here, is equal to log y to the base of x. Simple. Welcome to my channel, STEM Cafe, where we make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, enjoy, or exciting. So please, I appreciate you to subscribe, because from our record, it is observed that out of those who are watching, we have so many people watching, but very few are subscribers. Please assist to encourage and motivate us. Like, share, comment, even give us some challenges, by giving us questions and whatever. At the same time, I like to give you this information that we have some classes, you can register. If you have friends, if you have siblings, if you have children, they can register. The channel to do that is in the description. Thank you. Now let's go on with this. Another one is in indices. You know that if we have something like this, x raised to power a equal to z. So let's make this one, let's make it L n equals x raised to the power b. Therefore, L times n is equal to z. You can see that. Now, let's break this one to logarithm form. So in this place, you can say a equals to log lx, this x. B equals log xn. You can see this. Now, you can see that this is z. Therefore, a plus b equals log x z. You can see this now. But z is equal to L times n. So what does this mean? It means that log x L times n is equal to a plus b. From this, you can see. And that is equal to log xl a plus log L to the base of x, please, and log n to the base of x. You can see. So when we have products, we are going to add the logs. That is for the power. You can see. So this is the next one. You got this. So when we have log xl times n, is going to be log xl log l base x plus log n base x. Please take note of this. So when we are having products, we are going to have summation of the logs because it represents the power. In the same vein, when we have x raised to power a divided by x raised to power b, let's call that w. So which should be x raised to power a minus b. So if you follow this reasoning, you will realize that log w to the base of x is equal to log a minus b is equal to a minus b. And by the time you look at that, is equal to, yes, is equal to a minus b. So I don't want to. So which should be equal to log. So let's still use this log ls minus log m with x. So you can see. So if it is products, it's going to be addition of the logs. If it is subtraction, if it is division, it's going to be subtraction of the logs. You can see, because the log is about the powers. That is it. Please take notes. It's very simple. Just follow the reasoning from the indices and you'll get it. Now let's look at another situation. I have something like this. Y raised to power b. Let's say y raised to power k is equal to x raised to power n raised to power k. Where y equals to x raised to power n. You can see, if y is equal to power k, all of this will be raised to power k. Now let's look at one thing. In this situation, you get it? We have log x, log y base x is equal to n. You can see that now. equal to nk because of this. nk. So we can still make it like this. So it means that log xy is equal to n. So this power, which means that this k can come to this front, and then so it's going to be kn. So what we are trying to derive here is that when we have this power here, we can bring it out to multiply this one. That is, when we have y raised to power k is equal to x raised to power n k. You get that? So, which means that for y raised to power k now, we can now say log y base x is equal to n. Therefore, this k now can come to this front. So, anything you raise this power to here, just use it to multiply this log here. It subsists. Do you understand now? That is this power here, you don't need to start manipulating again. Just bring it out to multiply this whole thing here. That gives you your answer. So, another one I want us to look at is this. We have a equals to a raised to power 1. That's sure. Now, which means that log a to base a is equal to 1. You can see log a base a is equal to 1. So, from here, let's quickly look at the next one. I can now say that log a raised to power n, reasoning from this place, will be equal to n log a base a, which is equal to n, because this one is equal to 1. Log a base a is equal to 1. So n log base a is equal to n. So if you have it like this, it's going to give you n. So you can see that it's very, very simple. Another one I want us to look at is this. If I have x raised to power 0, you know that one gives me 1. You know that one gives me 1. So it means that I can now say that log 1 to the base of x is equal to 0. Which means that any number, the log of 1 for any base is equal to 0. The log of any number, the log of 1 to any base is equal to 0. That is what that is saying. I also like to repeat this. For numbers less than 1, the log is always negative. That is from 0 to 1. From 0 to 1. The logarithm is always less than, is always negative. But for 0 below, for 0, for numbers less than 0 and 0 is undefined. The log is undefined. When the number is less than 0 or equal to 0, log is undefined. Logarithm is undefined for this one. Logarithm is undefined for this one. Yes. Let's look at another situation. Now let's look at this situation. If x raised to power n now say n equals log y to the base of x. And we can also say that n equals log z to the base of y. You can see that. We can also say that z is equal to x raised to power n raised to the power of n. So from here we can say that n m is equal to log z to the base of x. Log z to the base of x. Now you can see that this is n, this is n. Let's bring it in. So you can now say log z to the base of x is equal to nn, that is log x y times log y to the base of x. So we can say log z base x is equal to log y base x times log z base y. You can see, just like chain rule. So this one comes to this place. You can see y, and then this one comes to this place. So what are we trying to do here? We are trying to change the base. You can see. So you can see that log xz is not log z base x is equal to log y base x times log z base y. So if you have it like this, and your calculation or your working, there are some situations where you can reason out like this to make it easy and to get your answer. So this one is done like this. Now let's look at another situation. If I have y equals to x raised to power n, therefore x will equal to y raised to power 1 over n. That's given, that's taken, have it? Then you can now look at it like this. N equals to log y is x, and 1 over n equals log x is y. You can see that this one is reciprocal of this. Therefore, you can say that log y base x is equal to 1 over log x base y, or vice versa. It depends. So you can see it is the reciprocal. So once you know this, you can easily also manipulate like this. Now, in this change of base here, we can also bring this one into this place. You know that log y base x can also be 1 over log x base y. So log zx can also be taken to be 1 over log y x times log So please note, this is for those who are about to write the matriculation examination. For those who are in the lower classes or who are just starting, the way they will be taking is different. So we are rushing this, so it will be like intensive class for them. So from this, you can have taste of what we do in our classes. Try to join on time so that you can catch up. Thank you very much. Let's go into some work examples. You can come across this in multiple choice question or normal theory question, depending on the kind of exam. We have this. It says if log 18 to the base 3 plus log 3 to the base 3 minus log x to base 3 is equal to 3. Find x. We have known that where we have addition is multiplication. Where we have subtraction is division. So we can easily say that log 3 into 18 times 3 divided by x is equal to log 3, okay, let's make it like this, is equal to 3 log 3, 3. Log 3 is equal to 1. You understand that? So it's equal to log 3, 3. I could have subtracted here, I will do it like that, and you see. So here I'm going to have, so this one is going to be log 3, 18 times 3 over x is equal to log 3 raised by 3. Log 3, 27. This one is when you are, required to explain the full way you get your answer. Now this one is going to give me, so this log 3 I'm going to remove it. So 18 times 3 over x is equal to 27. So x equals to 18 times 3 over 27. So this one, 9. So x equals 2. X equals 2. Another way we can do it straight is this. Log 3, 18 plus log 3, 3 minus log 3x is equal to 3. This is 1, Log 3, 3 is 1. So I can now say log 3, 18 minus log 3x is equal to 3 minus 5, which is 2. Fine. Now, I can now say log 3, 18 over x is equal to 2. And I have known that this one is 9 outright, but I might still say 2 log 3, 3, which is equal to log 3, 3 squared. If I have to do my exams, I have already known my answer here. I have already known it. I have 18 over x is equal to 9. Therefore, x equals to 18 over 9 is equal to 2. So whatever way, it depends on the kind of exam you are doing. If it's multiple choice question, you don't need all these things. The first step, second step is getting your answer. Now let's look at some examples. The first one says simplify log a to the base 10 and log 4 to base 10. So the first one, log 10, log 8 base 10, log 4 base 10. That's going to give us, for ease in handling, we break this one to the base that is common to the two of them, and the base is 2. So let's make it like this, log 10 2 raised to the power 3, that is 8, over log 10 2 raised to the power 2. From what we treated the other time, these powers can come to the front like this, and this is going to give us 3 log 10 2 divided by 2 log 10 2. This one we cancel this, So we have 3 over 2. have said that when we have difference like this, it means division. So we can now say log 8 over 4 base 10 divided by log 4 over 2 base 10. So this is log, and that gives us 1. So the answer to this one is 1. The answer to the first one is 3 over 2. So you can see how simple logarithm is, but it's very important in mathematics. Now this one says, given that log 2 is 0.69, log 3 is 1.10, and log 7 is 1.90, all to a specific base. All to a specific base. The base I don't know, and I don't even have to find the base. So thank God. Find log 10.5 to the same base without using table. You know that 10.5 will be equal to 21 divided by 2. And that is equal to 3 times 7 divided by 2. So what does that mean? So log 10.5 will be equal to log 3 plus log 7 minus log 2, which will be 1.10 plus 1.90 minus 0.69, and that is 3.0 minus 0.69, that is 2.31. So that's the answer for the second one. The third one is, if log y to base 2 is equal to 3 minus log x to the base 2 and log x raised to the power 3 to the base 2, find y when x equals to 4. So I can quickly write like this: log y to base 2 is equal to 3 minus log 2 4 raised to the power 3 over 2. And you know that 4 is 2 raised to the power 2. So I can still write this to be 3 minus log 2 squared times 3 over 2, which will be 3 minus, this 3 will come here, 0. So you can see, so log 2y is equal to 0. Therefore y is equal to 2 raised to the power 0. And from here, from what you have derived in the first place, you have said any number, logarithm of 1 to any base is 0. So thank you very much. The tip of the iceberg of what we do in the class. For more, you can contact through the channel in the description. Thank you very much. Subscribe, share, comment, and like. Like. I appreciate you. Thanks for giving me the opportunity, and thanks for being patient up to this stage. I appreciate you all.